Hello again, thanks for tuning in to another episode of Naked Neuroscience, the podcast exploring the workings of the brain and the nervous system in our bodies and beyond. I'm Katie Haylor, and this month,
being active, taking exercise, reduces in the long term your risk of development of, for example, Alzheimer's disease.
I'm stepping out of the office / spare room / recording studio and taking a walk in nature, as I hear about the brain benefits of exercise and the ways in which the great outdoors can do us good. Plus, as usual, we're joined by our local experts to digest some of the latest neuroscience news. Around 7 to 8 million adults in the UK are on statins, and they work to lower the amount of quote-unquote bad cholesterol, known as low-density lipoprotein, in the blood. High levels can be dangerous and are linked to cardiovascular problems. Like all medicines, statins have side effects, but this does seem to be a particular problem for some people when it comes to statins, and can lead to patients stopping the tablets altogether as a result. Muscle aches and pains are common among the reported problems. In the paper, cognitive neuroscientist Duncan Astle looked at this month, by comparing the side effects experienced from people on statins against those experienced by the same people on identical-looking dummy pills, a team from Imperial College London set out to explore whether these side effects were due to the actual drug or if something else could be going on. What they found was something called the nocebo effect, where being concerned about feeling worse whilst on the tablets means they did actually feel worse.
So in the study, they had 60 participants who had previously stopped taking statins because of the side effects, and they were randomized into different groups, and they were actually given different pots of medication. And in some pots, they would contain statins, and in some pots, they would contain placebo pills. Participants themselves at any one time were blind to what type of pill they were taking, and the people running the study were blind to what type of pill any participant was taking at any one time. And they used a scale to rate from 0, no side effects at all, to 100, the worst imaginable side effects.
So what did they find out then?
When you're taking a statin, your average score on the 0 to 100 side effect scale is 16.3. When you're taking a placebo, it's 15.4. And when you're taking neither, it's 8. So whatever pill you're taking relative to taking no pills, you experience significantly more side effects. But the difference between the statins and the actual placebo is very, very small. In fact, 90% of the side effects are present in the placebo condition, which implies that they have little to do with the active ingredients of statins and more to do with people's expectation of the kinds of side effects you get when you take statins.
Do you think this is specific to these particular people? Are they particularly vulnerable, or could it be quite a generalised thing?
It may well be that these are all people who have tried taking statins and discontinued because of the side effects. And that could mean that they are a special but significantly large subpopulation of individuals who experience these kinds of side effects enough that it's easy for them to think that when they're on the statins, these are the results of the medication that they're taking. The other way of thinking about it as well is the nature of the drug. When people decide to take statins, it's not as simple as this is the cure for A or B, or this will prevent you from getting condition A or B. In reality, it's about adjusting your risk. And so when GPs decide their patients should go on to statins, what they're doing is evaluating the potential benefit in terms of reduced risk with the potential cost in terms of any side effects. And so because everybody is so familiar with what the side effects are and the fact that people experience the side effects, I think it creates the expectation that there will be side effects. And thus you start to code any headache, any feeling of being a bit sick as a side effect of the medication. Whereas as these data show, actually your expectation can drive those effects also.
Do you think it could be particularly prevalent in cases where you're taking a drug, you're trying to maintain a status quo? So if it's working, you might not see any sort of outward result.
Exactly. So as far as I know, the only way that you would know if the statin was working is when you did your LDL cholesterol count, right? So you won't spontaneously find out and start feeling differently if the drug is working. And I think that that creates this perfect scenario for experiencing a nocebo effect.
So did they then tell the participants what had happened?
They did. So once the results were revealed to the participants, half of the trial participants were then able to restart statins. And as far as we know so far, they're still on those statins. It demonstrates that when you provide participants, or in this case patients, with information about the likelihood that their side effects are actually being caused by the medication they're taking, people are actually able to readjust the kind of priors and beliefs that have presumably have given rise to those symptoms in the first place, such that they're then able to successfully restart the medication.
So what do you reckon that means for patients and compliance with taking these sorts of medicines?
Data like these could be put into an incredibly easy to read, digestible format that could be given to patients when they start taking things like statins, so that they can be primed to realize that actually much of what they consider to be a side effect of the medication might actually have nothing to do with the medication itself. And you may well start to find that you get a reduced rate of dropout through side effects.
Duncan Astell from Cambridge University. And that study was published in the New England Journal of Medicine. I've also actually interviewed the study author about this work as well. If you'd like to hear more, you can find that interview on the Naked Scientist website, nakedscientist.com. Now, it's been well over half a year since the Naked Scientist office was inhabited, but what can the digital interruptions that come with many jobs, those chat windows, emails pinging into your inbox, do to our stress levels? This month, perceptual psychologist Helen Keyes looked into a study conducted before lockdown in a mock-up open plan office that asked this very question.
The researchers recruited 90 working age participants. They had to pretend to be employees of a fictitious insurance company, and they did things like typed up some handwritten notes, arranged meetings with clients, and some simple computations, some sales computations for this fictitious company. The participants were divided into 3 groups. In the first group, they were just the control group, and somebody pretending to be from HR came in and had a friendly chat with everybody. In the second group, somebody from HR came in and said that, surprise, we're going to evaluate you all to see who's going to get a promotion. And then in the third group, those people also had this HR conversation where they're going to be evaluated, but they were also constantly interrupted using a chat feature coming from their pretend line manager and required immediate responses each time. While they were undergoing this workplace environment scenario, the researchers measured their cortisol levels from their spit. So we know that cortisol is a stress hormone and it increases when we're stressed. They also measured all of the participants' heart rates continuously, and they measured some subjective measures of stress, mood, nervousness, those type of things, self-report measures from the participants. And they found the idea of you're about to be evaluated significantly increased all of your biological measures of stress in both of the evaluation conditions compared to the control.
That makes sense, right?
It makes total sense. However, in the stress condition where you're being evaluated and you're being interrupted, your cortisol levels doubled. So you were twice as stressed out physiologically. However, and this is quite surprising, those people who were in that interrupted condition, despite their higher cortisol levels, they reported feeling less stressed and feeling happier than those who were just in the being evaluated condition. And a nice explanation for this is down to the cortisol itself. So we think of cortisol usually and its long-term effects, which can be quite negative. So it can lead to fatigue, anxiety, depression, digestive problems, and even is associated with weight gain. But the short-term effects of cortisol are quite interesting. Cortisol is an adaptive response of the body to stress, and it's there for a reason. It actually increases your blood sugar, gives you a temporary spike in energy, improves your memory, and even increases your pain threshold. So short-term cortisol bursts have a really useful response. And it looks like in this last really stressful condition where you're being evaluated and interrupted, that extra cortisol burst actually makes it easier for you to deal with that stressful scenario. However, in the long term, if that really was your office environment with the constant interruptions, that long-term cortisol exposure is going to have negative effects on your health.
Do we know what it does to productivity? Because constant interruptions via emails and other things is a reality for a lot of people in the workplace.
Oh, without a doubt, it reduces your productivity. And there's a huge amount of work done on this, whether it's to do with working in open plan offices or those general interruptions to your workflow. Absolutely, it decreases productivity. It's very difficult for us to maintain focus or get anything done when we're interrupted. But while there have been a lot of studies on that kind of cognitive effect that we perform more poorly when we're interrupted, there hasn't been as much of a focus on stress and well-being. And that's a newer aspect of this type of research. Stress isn't always a bad thing. And a lot of situations in our life where we need to progress or change or get to the next level or further ourselves involve some levels of stress. It's not always a bad thing to be stressed. However, sustained long-term stress is a negative thing for our health.
Do you think there's anything particularly pertinent about this study as we're in a time where a fair few people are working from home, if their job facilitates that?
Reading about open plan office was almost nostalgic, but things have radically changed. Like you say, we're not in that environment where we're in front of other people. So it's a bit less threatening. If something is happening, you're not in front of other people when that's happening. However, I would agree that there is much less downtime, much less off time, much less time away from your screen and notifications and your computer. I think there's an awful lot of work still to be done on that, on the general effects of the pandemic on our working behaviors.
There are certain tasks you can do alongside each other very happily. There are certain other tasks that you can't if both tasks draw upon similar resources. So, for example, if you're trying to write some text whilst listening to music that's got lots of lyrics in it, it can be very difficult because it's very similar neural systems that you use for sort of subvocal kind of rehearsal of what you're writing are consumed by processing the lyrics of the songs, whereas lots of studies have shown that actually certain types of white noise or music that hasn't got lyrical content can actually be quite facilitating. So it's interesting that the type of thing that's going on in the background can actually either kind of hinder or help productivity.
Duncan Astle ending that interview, and before him, you heard from Helen Keyes. And as usual, if you'd like to follow up on the references to these papers, the links are on this episode's show page, nakedscientist.com/neuroscience. If you click on the interview for this section and scroll down, the references are listed below the interview transcript.
The USA's National Institutes of Health has got thousands of patients with diseases they can't explain. For investigator Dan Kastner, it was time for a new approach.
I'm going to do things backwards.
But what he didn't expect was the unlikely coincidence that would connect the dots.
It is fact stranger than fiction.
Find the story on November's episode of Naked Genetics, wherever you get your podcasts.
At the time of recording, here in the UK, we're in the midst of a second lockdown due to the coronavirus pandemic. And with winter on its way, the days getting darker, and without my usual cycling commute to Naked Scientist HQ, I'm trying to regularly schedule time for exercise, even if it's just in the house or a brief walk around the block. And judging by how difficult it is to order dumbbells at the moment, I'm sure I'm not the only one. So for the rest of this episode, if you can, and social distancing allowing of course, why not pop your shoes on, step outside and get the blood pumping and hear why movement is not only good for the body but also for the brain. And wherever you are, why not take a moment to appreciate the natural world as we hear why and how nature does us good. On that note, I'm going to step outside. I'm trying not to trip over my cat who's decided to sit right in front of me on the doorstep. So, firstly, let's limber up and jump into how exercise can actually change the structure of the brain. Anya Kelly is a physiology professor at Trinity College Dublin, who's particularly interested in exercise in relation to how the function of the brain changes as we age. It's not the only factor in ageing well, but as Anya told me, it's rather a big one.
Being active, taking exercise, reduces in the long term your risk of development of, for example, Alzheimer's disease. And what I'm interested in is understanding how exactly that happens.
I have been sitting for most of the day.
Yeah.
So I think, as we're talking about exercise, I'm going to have to stand up a little bit, move my chair away, and challenge. I want you to challenge me to do a couple of squats.
Okay, well, squat away, absolutely.
Okay.
And I think
I'm not sure about my technique here, but I'll give it a go. And whilst I'm holding the microphone as well.
Yeah, make sure your knees don't come too far and over your toes, or you'll be in the wrong position. Try to keep your back straight.
That's 3.
Keep going.
4. How many do I have to do?
I would say do 10 and then stop.
Okay.
Just get the blood moving.
Oh, I'm feeling warm already. I'm on 7. I'm wearing a woolly jumper. That wasn't very wise, was it?
Okay.
Okay.
Oh, well, 10 isn't
8,
too bad.
9. I'm feeling pretty good in it, actually.
Excellent. Good.
10. Right.
All your synapses should be firing now at this stage.
Got my blood flowing.
Good.
It's pretty obvious that doing exercises like that over, a longer period of time is good for my body. But scientists like yourself reckon this is actually good for my brain too. So perhaps you can tell us a bit about why exercise is good for the brain.
You're right. I mean, exercise is so important to general good health and good health of all of our organs. But there are several things additionally that it can do specifically for the brain that have an impact then on brain function in the long term. One of them is a process called neurogenesis, literally the birth and development of new neurons. It was thought for a long time that this didn't happen in the adult brain, that once we reached the age of full development, that we couldn't develop any new neurons. And when the reports first came out about maybe 40 years ago or more, that perhaps new cells could be developed in the brain, it was sort of dismissed because the dogma was that it just didn't happen. Now we have really good evidence that, in fact, the adult brain does consistently produce new neurons throughout life. So effectively, you have stem cells in particular regions of the brain, and given the correct stimulation, they're going to make more of themselves, and they're going to develop, into mature neurons. And that process only happens in a couple of discrete regions in the brain, and one of them is the hippocampus, which is very important for learning and memory. And it turns out that probably the best stimulus for neurogenesis in the brain is physical activity. So exercising directly results in the production of these new neurons within the brain in regions that are important for learning and memory. And this perhaps then is the link between exercise and preservation of brain function, particularly memory, throughout life.
Is there a link here with mental well-being? I guess I'm specifically thinking about things like stress and depression, because it's sort of commonly understood that exercising regularly is a pretty good idea for your mood.
Absolutely. So again, on a couple of fronts, and there could be a potential neurogenesis link here as well, because certainly in animal models, antidepressants can stimulate the same kinds of molecular and cellular changes that exercise can in particular regions of the brain. And neurogenesis, it's being analyzed in the context of diseases and disorders of the brain, Alzheimer's disease, Parkinson's disease, multiple sclerosis, and indeed things like depression. So really, it could, I suppose, be a therapeutic target. So exercise itself, in terms of taking more exercise as a preventative measure or even as sort of an adjunct therapy for some of these things, but also if scientists like myself can understand the fundamental biological basis of how exercise is doing this, then that might be a target, for example, for drug therapies, for people maybe who can't exercise because of disability or, fragility. There might be some kind of a pharmacotherapy or a drug therapy that could mimic the effects of exercise on the brain. I mean, that's very aspirational and it's in the long term, but it's a possibility.
So you wrote a recent article in The Conversation about the benefits of exercise for the brain in terms of actually changing brain structures. Can you take us through that? Because you mentioned memory, which you've just mentioned briefly. And then I think you mentioned blood vessels and also inflammation. Maybe we can start with memory and learning.
Yeah. So again, this is all very much linked to some of the things that I've been talking about, and particularly this hippocampus region of the brain that's important in memory. A number of studies have used MRI scans to sort of visualize the brain and look at the structure of the brain and the volume of the brain. And we know that some literal shrinkage of the brain can happen with age, and that can be accelerated very much in things like Alzheimer's disease. So some studies have shown that taking regular physical activity, sort of a prescribed exercise program, can actually reverse some of that age-related shrinkage of these particular brain regions, for example. And again, that might very well be linked to this whole area of neurogenesis, or being able to develop new neurons. On the large scale, when we just think of the whole volume of the brain, or indeed of particular brain regions, that's a structural change. One of the other things that we know happens with exercise is that it can stimulate the production of new blood vessels. This is something called angiogenesis. This happens in your muscles. Okay, if you work out and try to sort of, bulk up your muscles and increase the size of your muscles, you're going to have some growth of new blood vessels along with that to support the new muscle tissue. And pretty much the same or a similar kind of thing can happen in the brain, because we know that with exercise, new blood vessels develop in the areas where neurogenesis is taking place. So the blood vessel development and the development of new neurons are happening hand in hand. And this means that those newly born neurons will get the blood supply that they need to survive and to function properly.
What about inflammation? Because it seems more and more that inflammation is being implicated in quite a lot of disease.
Absolutely. The immune system is fascinating because it's so complicated, and it consists of so many different cells and different areas of the body that can, secrete different molecules. When we think about physical activity and exercise, we have to think of the flip side of that, which is being sedentary. And not being active is the source of lots of problems in the body.
Oh dear.
And, I know, and particularly at the moment when a lot of us are kind of confined a bit more to our houses and we're not moving around as much as we normally do. But when you are sedentary, that increases the risk of obesity, type 2 diabetes, certain forms of cancer, for example. That again is linked to the immune system, because it creates sedentary behavior and bad diet and so on, creates a sort of an inflammatory environment within our tissues. That inflammation is linked to some of these conditions. And when we think of the brain, it's linked to age-related neurodegeneration, Alzheimer's disease, and so on. But the good news is that moving counteracts that. Exercise has quite a powerful anti-inflammatory property. So it can counteract these sort of pro-inflammatory events or pro-inflammatory changes that happen due to sedentary behavior and other things. So it can kind of modulate the function of the immune system towards sort of an anti-inflammatory type of approach. And when we think about what that might mean for the brain, we know a lot more now about neuroinflammation, inflammation in the brain, and how that's linked to age or degeneration or Alzheimer's and so on. And we know some of the cell types that are involved as well, and we know quite a bit about the biology of those cells and how they act. Exercise is able to change the function of those cells away from being very chronically pro-inflammatory and damaging, to sort of switch off that kind of inflammatory activity of those cells. We can have inflammation in the brain. We do have inflammation in the brain, but it seems that exercise is able to counteract that. And that, again, is another mechanism by which exercise is helpful and protective for the brain.
When you talk about exercising for the benefit of the brain, Do we know, has there been research done to indicate how regularly you need to exercise for there to be a benefit?
We don't have specific guidelines for the brain. What it appears is if we meet those recommended physical activity guidelines, for adults, that 150 minutes of sort of moderate intensity exercise per week or 75 minutes vigorous activity. And then we need to, do things that will build strength and flexibility as well, just for general health. That's for adults. For children, it's an hour per day. We know that children, in particular school children, are not meeting the physical activity guidelines, which is a major worry for things like cardiovascular health and, metabolic health, but also potentially for brain health, because some of the studies that are coming through, at least in animal models, it seems that early life exercise, and this is something that I'm interested in working on myself, even if you are sedentary later in life, still has protective benefits. So we really need to be active, particularly when we are younger, to sort of, I suppose, build up some of that benefit. I think consistency is the thing. So being consistently active over long periods of time. But in terms of maybe it should be 200 minutes a week specifically for the brain, we don't have that level of detail because the science is still in question at the moment. I think, the best advice is to follow the general guidelines for good health and just to move as much as you possibly can.
Anya Kelly there from Trinity College Dublin. Right, well, I've come back around the block now, and I'm actually lucky enough to live quite close to a little park with trees, shrubs, and a bit of grass. And this leads rather nicely onto the final interview this month, which is with psychologist turned science writer Jill Suttie from the Greater Good magazine out of the University of California, Berkeley. Back in 2016, Jill wrote an article about how nature does our bodies and brains some good. So I called up Jill to get her thoughts on my walk and more.
Exercise is very stress relieving, but there is an augmentation of doing exercise in nature or in a green space of some kind. And there have been experiments that have shown that when people walk in a green space, a nature setting, or even when they just look at scenes of nature or videos of nature, there's something about that relaxes the stress response. And in the brain, it would be the amygdala. It seems to affect the amygdala, which is part of the sympathetic nervous system, which is our basic flight or flight response system. It seems to soothe that and increase activity in the parasympathetic nervous system, which helps relax us. So that's kind of a broad finding around stress. The other big way it seems to impact us is giving us a break from cognitive activity or activity that involves a lot of concentration and attention. So, for example, there have been studies that have shown when you spend time in nature afterwards, your brain has had a chance to rejuvenate in a way, and it makes you more able to solve problems, have better recall on memory tasks, things like, so what you're doing, it sounds like a good thing to do because it should help to relieve the stress and also to relieve the cognitive overload that you might have been experiencing by playing with your computer or looking at all these different screens. In terms of why does nature do that? There's more research on how it does it, or showing that it seems to have an impact. But why? There are only theories, really. One of the big ones comes from Roger Ulrich. He calls it biophilia. Well, it's also been coined by other people, but he's looking at possibly our connection to nature, which we've evolved to have. So we have a natural affinity for natural scenes because we needed elements in nature to survive and to feel safe. If you're in a forest, you have some kind of protection potentially from predators. Or if you are able to see far and wide, you have some ability to scan the horizon and see if there's danger on the horizon. And then there's also, of course, food sources and oxygen and all of these things that we get from nature that are very just basic to our survival. So we have a natural affinity for those spaces, and being in them, there's a theory that because of that, when we're in them, it creates positive emotion, which is also stress relieving.
It's really interesting that you said earlier, even if you're just to look at a picture of a natural scene, looking at nature makes us feel less stressed. Is that right?
It is right. And I think you can pretty much see how that plays out in just the world. You know, how many people are posting like these beautiful nature scenes on their social media, and how many people go to these sites where these, you know, the most fantastic nature photographs around the world. And there's a real attraction to that. I think it does help. I mean, it might not be exactly the same as being outside, because you get other benefits from being outside, and it's a more immersive experience, and you're smelling and you're hearing sounds and other things that you might not get from just looking at a static picture. But they have done experiments where, for example, they've had people look at nature videos. They would take people in a lab and expose them to a very stressful event of some kind. Often they used video, like movies that were scary or stress inducing. And then afterwards, they would have people either look at videos of nature or videos of urban scenes or other non-natural settings and see, and then they had them hooked up, you know, to all of these instruments to help measure physiological response. And they find that when people look at the nature scenes, you know, all of these, everything, they can recover from that stress much more quickly. So it isn't just being outside, although that is really beneficial. I would argue maybe much more beneficial. You can just by kind of seeing a natural scene feel better.
Is there evidence that being out in nature can help us to be a bit less brooding, or to ruminate less?
Yes, there definitely is. There is some work out of Stanford. Greg Bratman did some studies on looking at how being out in nature affected people's moods. And what he did is he set up an experiment where he had people walk along a road in Palo Alto, I guess, where Stanford is, or walk through a wooded area. And, you know, they calibrate it so that it's the same amount of physical activity and, you know, same amount of elevation gain, that kind of thing, to try to keep the two experiences mostly equivalent, except for the nature element. And then he found that there was decreased rumination in the people who walked in the wooded area. And he actually also did a second follow-up experiment where he looked at what was going on in their brains and was able to find that there was this part of the brain that's connected to rumination. It had decreased activity, but increased activity in that part of the brain is what's connected with rumination. You can see other experiments too, where they've looked at things like tree cover or tree canopy cover in a city and found where there are trees, there's less crime, even if it is any different than a place without tree cover. So there is something soothing about nature that seems to impact our moods and our stress levels and our overwhelm that might have social effects as well.
So can being in nature change the way you behave towards other people?
There have been experiments showing that natural elements or being in nature seem to create more kindness towards others, and in various ways. So how have they measured this? Well, there was a series of experiments done actually at the University of California, Berkeley, where we are at, and our faculty co-founder, Dacher Keltner, was involved in some of these experiments where they basically, for example, they had people watch nature scenes, and then they had them play these economics games or other kinds of scenes, other non-natural scenes. And they had them play these economic games that measure trust levels or generosity. And they found differences in the people who saw the nature scenes versus the other scenes, the non-nature scenes. You know, why is that? It could be tied to all the things that we've already talked about. It could be because of stress relief. But there's also been some evidence that looking to nature can inspire feelings of awe, which is something that Dr. Keltner studies in particular. And for those who aren't familiar with how they define that in psychology, it's like a sense of wonder coupled with a sense of being part of a small part of a larger universe, or kind of a small self feeling. And I think that particular element, the small self, might be tied to how people end up being kinder. They see themselves as less self-important, maybe, and they also feel good because a sense of wonder just feels magical. You know, when you see a spectacular sunset or amazing mountain ranges, or just even sometimes seeing the diversity of a forest can inspire this sense of awe and wonder. And that seems to be tied to being more helpful, kinder. For example, one of the other experiments they did was they had students at the university spend a short amount of time looking either at the tall buildings on the campus or at a grove of eucalyptus trees, which were very tall. And then they had this experiment afterwards where the person who was supposedly conducting the experiment, was conducting the experiment, but was a Confederate basically, they ended up dropping a bunch of pencils, looking like they had just dropped a bunch of pencils, and they saw who got up and helped them pick up the pencils and how many pencils they helped them pick up. And they could measure like how kind or helpful, altruistic these folks were being. And they found that just from that amount of exposure, looking at the trees, people were more helpful and experienced feelings of awe. So there is some evidence that being in nature or being exposed to natural elements seem to make people kinder or more altruistic or get along better with others.
So all the more reason to get some nature into your day. Thanks very much, Jill. Now, I'm getting a bit chilly. I'm going to head back inside. That's actually all we've got time for this month. Thank you to our guests. You heard from Anya Kelly, Jill Suttie, Helen Keyes and Duncan Astle. Until next time, thanks so much for listening, look after yourselves, and goodbye.